All right, hello and welcome everyone. In this video, I'm going to talk about preferences. This budget constraint stuff, that's a lie. So we're going to talk about preferences in the vein of Varian's intermediate micro. So this preferences is a chapter title in Varian. And so I'm going to walk through thinking about preferences. In the previous lecture, we talked about budget constraints. We introduced the price ratio. That was the constraint on what the market would permit consumers to do. This affected consumers' optimization choice by virtue of telling us what trade-off the market will allow. Now we're going to think of consumer preferences, which is going to give us the way in which consumers' own the consumer's own outlook, own perspective is going to govern the trade-offs that they're going to be willing to make. So here we're going to think about consumer preferences. This is going to be really important to analyze consumer choice, which is what we're after as part of consumer theory. We'll introduce indifference curves, the assumptions necessary to make preferences nice to work with, and the marginal rate of substitution, which is nothing other than the slope of the indifference curve. So previously we discussed in the budget constraints, we talked about what a consumer can afford. We didn't yet say anything about what the consumer actually wants. Now we need to introduce preferences so that we can talk about what the consumer wants. Remember, the goal of optimization, the goal of consumer theory is for the consumer to do the best they can given the circumstances. The given the circumstances part we covered already talking about the budget constraint. Doing the best they can is going to be determined by the preference structure. So here, this looks scary. I'm just going to use this to introduce some terminology, and then ultimately we're going to replace preferences with utility functions that would be way better to work with. But this is important to understand where that's coming from. So suppose we have two bundles, X1, X2, and Y1, Y2. This is the amount of the goods that we have. So in bundle X, I have the quantity X1 of good 1, the quantity X2 of good 2. In bundle Y, I have the quantity Y1 of good 1 and Y2 of good 2. We'd say the consumer strictly prefers bundle X to Y if we have this relationship. This is, think about like a greater than sign, think about greater than or equal to, and think about like equal to. This is indifferent. So strict preference means bundle X is better than bundle Y. This is like 3 is greater than 2. Consumer weakly prefers means the consumer actually could prefer it or could be indifferent. So this is be like 2 is greater than or equal to 2. Right? So this weak prefers means that this admits of also indifference between bundle X and Y. Indifference is if the consumer doesn't matter, doesn't care about between the difference of bundle X and bundle Y. They're going to be equivalent in terms of the consumer's preference. Now, we assume that the preferences are complete if the consumer can make a comment about the relative ranking of any two bundles. So basically, completeness just means you can compare any two bundles. You can say, I like bundle X better than Y, I like Y better than X, or I like them the same. Completeness is violated if you have two bundles, X and Y, and the consumer says, I don't know, when you ask which they like better. So completeness means either you like bundle X better than bundle Y, you like bundle Y better than bundle X, or you're indifferent between them. We assume preferences are reflexive when any bundle is at least as good as itself. So bundle X is at least as good as bundle X. Probably we're thinking about a situation where you're indifferent between them because it's the same. But here, this is important for the mathematical completeness of our preferences. We assume preferences are transitive when if A is preferred to B and B is preferred to C, A is preferred to C. So this is just standard transitivity. So if we have three bundles, X, Y, and Z, if bundle X is preferred to bundle Y is preferred to bundle Z, then bundle X must be preferred to bundle Z, right? Again, X1 is the amount of good 1, X2 is the amount of good 2 in bundle X, Y1 is the amount of good 1, Y2 is the amount of good 2 in bundle Y, and then similarly for bundle Z. So we use this really quickly. You notice I get away from it really quickly because we're going to be ultimately worrying about indifference curves. So indifference curves are going to be the set of all bundles that the consumer is indifferent between. Right? It's a collection of all the bundles that I like the same. So if we pick some arbitrary bundle X, we'd say the bundles that are weakly preferred to bundle X is the weakly preferred set. The weakly preferred set includes the bundles I like the same and the bundles I like more. So the weakly preferred set is going to be the indifference curve plus everything on higher indifference curves. So we'll see, that'll make more sense when I show the picture. So we say that the bundles the consumer likes as much as bundle X give us our indifference curve. The indifference curve is the boundary to the weakly preferred set. So in red here, I've got the indifference curve. These are all the bundles that I like the same as this one right here. And then these blue arrows are going into the collection of all the bundles I like better. So I said weakly preferred bundles are all the bundles weakly preferred to x1, x2. I should have made these the same color because the weakly preferred set does include this line right here. The weakly preferred set is the indifference curve plus all higher indifference curves. You could think of more indifference curves going through these bundles. We'll see that in a second. The indifference curve through the bundle, the important thing is it's going to go through all the other bundles that leave the consumer indifferent given to the given bundle. So the indifference curve is going to contain all the collections of bundles that are at least that are as good as the one you've got. That is, you like the same as the one you've got. I said sometimes it's helpful to draw arrows in the direction of the preferred bundles. In consumer theory, the better bundles are to the northeast. This is a situation where New York City is better than Los Angeles. Although being that I like the Southwest and Arizona, I usually think of the Southwest as being better. But we'll put that aside for now. For the purposes here, we'll think of New York City as being better than Los Angeles. The Northeast better than the Southwest. So better bundles are to the northeast. We're going to allow many different shapes of indifference curves, but we require they don't cross. So they can be straight lines, they can be convex, but they cannot cross. Why? If they cross, we have a violation of transitivity. So what this would be saying is, I like bundle X as well as I like bundle Y. I like bundle Y as well as I like bundle Z, so I must like bundle X the same as bundle Z. However, better bundles are to the northeast, which tells me the bundles that lie on this right here are to the northeast relative to bundle Z. So I must like these bundles better than I like bundle Z because it's to the northeast. However, these bundles I like the same as bundle Y, which I like the same as bundle X. So there's a problem because I like Y the same as Z. So how can I like these bundles the same as Y, but also more than Z? You can't. So we don't allow indifference curves to cross. Now we're going to move on to thinking about important shapes of indifference curves. We're going to have four main preference shapes: perfect substitutes, perfect complements, quasi-linear, and Cobb-Douglas. Perfect substitutes indifference curves are going to be downward sloping straight lines. So these are going to be situations where the consumer is willing to substitute one good for the other at a constant rate. Two goods are perfect complements if they're always consumed together in fixed proportions. You need to have them in the same proportion. These are going to give us L-shaped or right-angled indifference curves. This is interesting because to get onto higher indifference curves, you have to increase the quantity of both goods at the same time. Otherwise, you just move along the same indifference curve. I'll demonstrate that in a second. And so you could think of like, if you have one bag of chocolate chip cookies, how many batches of chocolate chip cookies can you make? Well, you could probably make one, maybe 1.5, maybe 2, depending on your recipe. Suppose I give you a second bag of chocolate chip cookies. Now can you make twice as many cookies? Not necessarily, only if you also have always also have the requisite amount of flour, sugar, brown sugar, and so on and so forth, right? So the idea is like with fixed proportions, like recipes and stuff like this, there's a particular requirement that has to be adhered to get into better bundles. And then my comment here, fixed proportion doesn't need to be 1-to-1. It could be 2-to-1, it could be 3-to-1, and then I'll show that a little bit later on. Here are our perfect subs indifference curves. So technically, perfect subs indifference curves would have the slope of slope of -1. I'm going to refer to subs and perfect subs anytime that you have interchangeability between the two goods. So substitutes are going to give us downward sloping indifference curves. And I've drawn these with intercepts. So this would correspond to where I exhaust my consumption or I exhaust my budget. Even though I haven't drawn income, this isn't a budget constraint, but this would be like I only consume, I shouldn't say exhaust, I should say this is where I only consume X, this is where I only consume good 2, this is where I only consume good 1, right? So that's what these endpoints are saying. And suppose like good 1 is Coke and good 2 is Pepsi. This is telling me that only drinking Coke is as good as drinking only Pepsi because they're on the same indifference curve, which is the same as having equal amounts of both cans or whatever. So those are perfect subs. Perfect complements are these right angles. And so here we have these L-shaped or Leontief preferences. And the idea here is that to get to a better bundle, you need more of both. So suppose I'm right here and you give me more of good 1. Oh, I'm just going to move down this arm. I like this the same as where I started. Or suppose you give me more of good 2. I'm just going to move up this arm. I like this the same as where it started. You have to give me more of both. So most people wear two shoes, a left shoe and a right shoe. So suppose you give me more left shoes, that's not helping me. Suppose you give me more right shoes, not helping me either. Suppose you give me a new left shoe and a new right shoe. Oh, now I've got a complete pair. So that moves me into a higher indifference curve. So that's kind of the interpretation for complements, goods that are used together. And that's why we have to have this preference shape. Interestingly, and this will be useful for optimization, the optimal solution when you have perfect complements preferences is going to be on this corner. So why? Well, think about the logic I just gave. To get into a higher bundle, you have to have more of both. And so this is going to tell me that the optimal has to be at these corners, because what's happening down here? Wastefulness. Here you've expended resources. This is a bundle that has more left shoes than right shoes. If left shoes are good 1, right shoes are good 2, this has more left shoes than right shoes. But those aren't free. I had to pay money for those, which means I've wasted budgetary resources without increasing my well-being. So rather than spending all this extra money on left shoes, I should buy another right shoe and move to a higher indifference curve. All right, there's other examples of indifference curves. This is useful for reinforcing your logic and intuition. Commodity is a bad if the consumer does not like it. So indifference curves would have a positive slope for bads. I'll show this graphically, but the basic idea is if good 2 is a bad, the consumer has to be given more good 1 to be able to put up with having good 2, which is a bad. I'll show you that graphically. A good is a neutral good if the consumer doesn't care one way or the other. If good 1 is a normal good and good 2 is neutral, then the indifference curves would be vertical. There you can give me more of good 2, it's not going to change my well-being. That's just as we saw with perfect complements. Here's the example, and then I'll show pictures in a second. If there's only 2 goods, if more of good 1 is always preferred to less, well, less of good 2 is preferred to more. Good 2 is a bad. Then what will the indifference curve for the consumer look like? It'll be these right here. These are our indifference curves for bad. Good 2 is a bad. Good 1 is a good. So what this is telling me is that as you're giving me more of good 2, as I'm increasing my vertical direction, you also have to give me more of good 1 to keep me on the same indifference curve. If you don't give me more of good 1, I'm moving on to lower indifference curves, right? Up into these ones right here are worse and worse indifference curves. Better indifference curves are, well, to the down right corner in this situation. But here, good 2 is a bad. To keep me as well off as I was before, you have to give me more of good 1 if you're increasing how much good 2 I have. Good 2 is a bad. Here, good 2 is neutral. To make me on a higher indifference curve, you have to give me more of good 1. Doesn't matter if you give me more of good 2, I'm going to be as well off as I was before. Then we'll talk about satiation. We're going to typically assume we're going to assume away satiation. We're going to assume there's no bliss points. There's going to be no points of satiation. This would be, suppose you have some most preferred bundle, and then the further away you get from this bundle, the worse the consumer would be. So this would be a situation like this. I'll talk about that in a second. When the indifference curve has a negative slope, the consumer has too little or too much of both goods. When it has a positive slope, they have too much of one of the goods. So then if you have too much of both, it means that both are bads. If you have too much of one good, I'm dodging my microphone, then it becomes a bad. So you'd have to reduce the consumption to be better. That's just justifying this picture here. We don't want this to happen, right? We're going to assume that for the rest of the course, this doesn't happen. So this is a problem. Why is this a problem? We want better bundles to the northeast. That's a problem because these bundles are actually worse bundles from this perspective, right? This is the same indifference curve. So I'm indifferent between this bundle and this bundle, which is telling me that if I have a lot of both goods or a little of both goods, I don't like that as much as having just exactly X1 star and X2 star, right? So this is a problem we're going to assume away satiation. In doing so, one of the assumptions we'll often make is that we have well-behaved preferences. We need 2 assumptions for this. The more is better assumption, and the averages are preferred to extremes assumption. More is better is monotonicity of preferences. If this is one bundle and this is another bundle that has at least as much of both goods and more of one good, you must strictly prefer the bundle that has more of one good. So this is saying preferences obey monotonicity of preferences. If you have 2 bundles, one that has 1 Coke and 1 Pepsi and the one that has 1 Coke and 2 Pepsis, you must prefer the one that has 2 Pepsis and 1 Coke to the one that has 1 Pepsi and 1 Coke to be consistent with more is better. Here we're assuming we're considering points before satiation occurs because we're assuming satiation is not going to happen. And what's going to happen with this assumption, with more is better, this is going to give us indifference curves with a negative slope. This is what's justifying that the better bundles are to the northeast, are towards New York City. So that's this. Better bundles are to the northeast, worse bundles are to the southwest, right? So this is the monotone preferences. The better bundles are in this direction, right? So relative to bundle X1, X2 that has this amount of good 1, this amount of good 2, the better bundles are this way, worse bundles are this way. That's monotonicity. We also assume the averages are preferred to extremes. So for averages preferred to extremes, what this has to tell us is that we would rather have a bundle that has an average amount of both goods than an extreme amount of the goods. So for instance, like graphically, what this is going to do is this is going to say, suppose we have two bundles in the same indifference curve, bundle X and bundle Y. Their weighted average is going to be at least as good or strictly preferred if we're consistent with averages preferred to extremes. What this is going to do is this is going to say this is the amount of good 1 in bundle X times a half, plus half the amount of good 1 in bundle Y is going to be how much I have in this average bundle. And then I'm going to take the amount of good 2 in bundle X and the amount of good 2 in bundle Y and take their weighted average, and that's going to give me my composite bundle. And if averages are preferred to extremes, I'm going to prefer this bundle, or it's going to be at least as good as strictly preferred. So the set of bundles weakly preferred is going to be a convex set, meaning it has the property that if you take any 2 points on the set and draw the line segment connecting the two, the line segment is going to lie entirely within the set. That's going to be this picture right here on the left. We have bundle Y, we have bundle X, and the average bundle is going to lie on the secant line, right? It's going to lie, this is a convex set, these bundles right here, and the average of these two bundles, the weighted average of bundle Y and bundle X, is going to lie on the secant line within the set. How do we know that this is averages preferred to extremes? Better bundles are to the northeast. So if you drew an indifference curve here, it'd be a higher indifference curve. It'd cross right here. The indifference curve going through here is going to be a higher indifference curve than this one, meaning it's going to correspond to a higher level of preference. We're typically going to assume we don't have non-convex preferences. What's the problem here with this average bundle? Well, you can draw an indifference curve that goes through the average bundle right here. Think of this W that's tracing this one that goes below. You could draw a lower indifference curve. What this is telling us is that actually I prefer this extreme bundle or this extreme bundle to this bundle because this one will be on a lower indifference curve. So that's a problem. Also with concave preferences, clearly this is going to be a lower indifference curve for this particular bundle. We're going to assume that we don't have picture panel 2 or panel 3, or is panel B or panel C. We'll assume we won't have. All right, so here's an example. AND consumes good X and good Y. AND's indifference curves are described by this formula. Y is equal to K over X plus 3, where K is corresponding to higher indifference curves. Which of the following is true? AND prefers bundle X, bundle 8-9 to bundle 9-8, 11-9 to bundle 9-11, hates Y, or likes Y, hates X, likes X, hates Y. We can eliminate C and D because these indifference curves are not going to give us upward sloping straight lines, right? So we don't have bads. So we're going to consume A, and we're going to consider A and B. So here's how we do this. I'm going to write this. This is my equation for an indifference curve. Let's write this as K is equal to Y times X plus 3. That's this. K is equal to Y times X plus 3. So bundle 8-9 would be, well, just evaluating, corresponding to a preference level or a level of utility of 99. 9-8 is going to correspond to 96. So indeed, yes, Anne is going to prefer bundle 8-9 to bundle 9-8. What about this one? 9-11 would give us a level of 132. 11-9 would give us a level of 126. No, we don't prefer 11-9 to 9-11. Right? All right, cool. Puppy study break. Hey, how about that puppy? Here's my puppy. I hear her upstairs. I hear the puppy upstairs playing with this toy that I covered in peanut butter that she is playing with. I hear it running around. Maybe you hear that I don't know. So I have to run up and make sure she's okay. All right, so then we'll introduce the idea of marginal rate of substitution. Marginal rate of substitution is just the slope of the indifference curve at a particular point. So whereas the price ratio was the marginal rate of transformation, that's the rate at which the economy is willing to allow the consumer to trade off one good for the other, right? We gave the example of coffee and cookies. If I bought fewer a smaller amount of coffee that frees up money that I'm not spending on coffee to buy cookies. And from my example in the budget constraint lecture, the price ratio was minus 1/2. That was the rate at which the market was allowing me to free up money out of coffee into cookies. The marginal rate of substitution is the rate at which the consumer is willing to trade one good for the other to stay on the same indifference curve. So this is the rate at which the consumer is just exactly willing to substitute one good for the other. We're taking away a little of good one, right? We're changing the amount of good one, replacing it with a little of good two to keep them indifferent. As these amounts become infinitesimally small, you can think of this as, rather than delta, so you can think of this as dx2 dx1 or dy dx. That's a slope, right? This is going to be a slope of the indifference curve. So definitely we want to use calculus. Indifference curves typically have negative slopes. So the sine of the MRS is often sine of the MRS is often negative. Just as we had with price ratio, very often I'll report the price ratio in absolute value and the MRS in absolute value. Don't let that confuse you. The budget constraint has a negative slope. Indifference curves have a negative slope. We're going to ultimately be comparing the trade-off governed by the budget constraint to the trade-off governed by the indifference curve. Negative to negative cancels, and so we can, without loss of generality, just talk in terms of absolute value anyway. So don't let that confuse you. If I talk about the MRS and I use a positive, no, it's negative. And if I use the price ratio and say it's positive, no, it's negative. But we all know this, and so Varian has a comment about that in the text. So that's not just me being, not just me doing my own thing. That's it's in Varian as well. So, and it's how economists are trained. All right, so here the slope of the indifference curve is the marginal rate of substitution. Here I'm just given the calculus argument, right? So if we change our consumption of good one by a little bit, change our consumption of good one by a little bit, think about the slope, think about what's happening if this change gets infinitesimally small, then this becomes a derivative. That's a slope at the point. The derivative is the slope of the line tangent to the point, right? So this line is going to give me my slope of the indifference curve at that point. Notice the indifference curve is going to have a steeper slope here and a flatter slope here, telling me that my MRS is bigger here in absolute value than it is here and than it is here. We'll have a smaller MRS down here, which tells us the rate at which I'm willing to give up good 2 for good 1 is higher here than here. Right? Here I'm willing to give up quite a bit of good 2 to get a little bit of good 1. Here you have to give me quite a bit of good 1 to make me want to give up a little bit of good 2. All right, Ann has indifference curves with this following equation, where the larger constants correspond to higher indifference curves. What's the slope of Ann's indifference curve at this consumption bundle? All right, well, we just talked about this, the slope at a point. It's going to be a derivative, right? So what we want to do here, I should have written this out, and I know I'm going to screw it up if I try to type it out. So what you're going to want to do is take dx2 dx1. Take this derivative with respect to x1. So what's this derivative going to be? Well, to take this derivative, it's going to be 1/2. So c is a constant with respect to differentiation. That's gone. So it's going to be 1/2 times a negative 4 is going to be minus 1/2. Reduce this power by 1, so it's going to be to the minus 1. So I'm going to have a minus 1/2 to the negative square root power. Okay, let's take 9 to the, and then 9 raised to the negative square root power. The slope of Ann's indifference curve, if you evaluate at the point 9, or for x1 is equal to 9, will be negative 2/3. So you can go ahead and verify. This is just asking us what's the MRS at this particular point. What's the slope of the indifference curve? That's Ann's MRS at this bundle. It'd be different somewhere else. This is a convex curve, but convex preferences, but at this particular point, the MRS is going to be minus 2/3. All right. Ann and Bob both consume only coffee and some cookies. Both have chosen to consume coffee and some cookies, and both have strictly convex preferences. Ann likes to have a great deal of coffee with a few cookies. Bob likes a lot of cookies with a little coffee. Both face the same prices and have chosen bundles to maximize utility, which is correct. Bob's MRS is larger in absolute value than Ann's. Ann's MRS is larger in absolute value than Bob's. They're equal. Their income depends on, no, that's silly. MRS depends, it's the slope of the indifference curve, so it's not income. Who has a larger MRS? Let's stop talking about income. That's silly. All right, so what ends up happening, it's actually Ann and Bob's MRS is going to be the same. Both have chosen to have some coffee and some cookies. Both have strictly convex preferences. they face the same prices for both goods and have chosen bundles to maximize their utility subject to their budgets. What's happening here, this is actually foreshadowing. This is a little bit too early to talk about in this lecture, but when they're optimizing, they're going to face the same trade-off from the economy as they are from both Ann and Bob face the same prices, therefore they face the same price ratio. Our optimization decision is you want to set your MRS equal to the price ratio. So Ann's MRS has to equal the price ratio. Bob's MRS has to equal the price ratio. So Ann's MRS has to equal Bob's MRS. And we hear puppy study break barking upstairs. So here's diminishing MRS, convex preferences. This is like my coffee and cookies example. So this would be a bundle with 2 cookies and 6 coffee. Here's 3 cookies and 4 coffee, so on and so forth. And I'm going to illustrate that the MRS changes along this indifference curve. So here at point A, I have a lot of coffee. I want to trade for cookies. Point D, I have a very little coffee, and I'm reluctant to trade for any additional cookies. So let's see this. Here I have a lot of coffee. I'm willing to give it up. And so here I have a very steep MRS. Here I have only a little bit of coffee, so I have a flat MRS. The MRS is how much coffee I'm willing to give up to get an additional cookie, right? How much of good Y I'm willing to give up for an additional good X. So looking closely here, going from A to B. So from A to B is 2, 6 to 3, 4. Here I'm giving up 2 coffee, right? I go from 6 to 4, that's 2 coffee, and I'm getting 1 cookie. And I can giving up 2 coffee, I can be just as happy replacing it with 1 cookie, so the MRS is 2. Going from 3, 4 to 4, 3, giving up 1 coffee from 4 to 3, getting 1 cookie, I'm equally happy. I'm on the same indifference curve, that's how I know I'm equally happy. Here my MRS is 1. If I'm going from 4 to 6, I'm giving up, if I'm going from 3 to 2, I'm giving up 1 coffee. If I'm going from 4 to 6, I'm getting 2 cookies. Now my MRS, the change in the slope of this line is going to be, slope of the line is 1/2 down here, right? The MRS is governing the trade-off I'm willing to make. With the convex preferences, I'm willing to give up more coffee for cookies, the more coffee I already have. I'm willing to give up less coffee for cookies, the less coffee I already have. And that's this right here. All right. So I'm going to go ahead and I'm going to figure out why that puppy study break is barking upstairs, but hope you enjoyed the video. See you next time.